All right, lesson 5-2, bisectors in triangles. First, we're going to apply properties of perpendicular bisectors, and then we're going to apply properties of angle bisectors in a triangle. So concurrent means when three or more lines intersect at a single point, and the point of concurrency is this same point where those concurrent lines intersect. Okay? A circumcenter of a triangle is when we have a point of concurrency where the three perpendicular bisectors meet in a triangle. And when we have a point of concurrency of the three perpendicular bisectors, it's kind of cool. What happens is we create a circumscribed circle about the triangle, because what happens is this circumcenter is equidistant from the vertices, and we'll do an example of that in just a minute. So circumscribed, as I said, that's when the circle is touching all the vertices of the triangle. So this is an example of a circumscribed circle. An InCenter of a triangle is when we have three angle bisectors that meet. And what happens for us InCenter, it's kind of cool. We can create an inscribed circle. So that's a circle on the inside. So here we had a circle on the outside touching all the vertices. And then we can also create a circle on the inside that touches all the sides of a triangle. So our first theorem for today is a circumcenter, and I need for you to take out your compass, and I need for you to take out your straight edge, because we're going to be doing a little construction here. So a circumcenter is created by the perpendicular bisectors, and as I said up here, it creates a circumscribed circle where it touches all the vertices. So we're going to create that down here. So first we're going to find that perpendicular bisectors. So if you remember perpendicular bisectors, you need to open up your compass a little bit more than halfway and create an arc. And I'm just going to go ahead and extend my arc all the way for this other side as well, because we need it for the whole triangle. Then we're going to create an arc here and make it go all the way, like so. And then go up to the third vertice for your last one. There we go. Okay, so now we have all of our arcs. Now we're going to find what the perpendicular bisectors are, where it meets. So we're going to use our straight edge to connect the dots here. And on the all three of the sides. And what you should find if you constructed it correctly is they should all connect in one single point of concurrency. This is the point of concurrency of the perpendicular bisectors, and it is called a circumcenter. So the name of this is a circumcenter. And it was created by using the perpendicular bisectors. So remember what I said, what was cool about this is that you can create a circumscribed circle. So we're going to do that. So if you take your compass and put your point of your compass on the circumcenter and have the distance or the size of your compass be the same size from the circumcenter to one of the vertices. So just like that. And I'm tightening up my compass here, so it's nice and tight. Okay, now I'm going to draw a circle from that, and it should, if I did it right, hopefully I did, it should touch all three vertices exactly. It's kind of hard to do this without turning your paper, so you might need to turn your paper. Like so. Okay, there we go. That's pretty good. So, the cool thing about the circumcenter is that it is equidistant from the vertices, okay? Which means that if I take from the circumcenter to the vertice, all these lengths should be the same because they are radii of the circle itself, okay? So that's that. Now, if this is an acute triangle, because all three angles are acute, if you had an obtuse triangle, and I'm not going to construct this, I'm just going to quickly sketch it. And if you were to create the perpendicular bisectors of an obtuse triangle, what you would find is that they would meet outside the triangle. And so your circumscribed circle would be way out here like that, something like that, kind of going off the page here. If you were to have a right triangle, so if this was a right triangle, what you would find if you made your perpendicular bisectors is that it would be on the right, or excuse me, on the hypotenuse of the right triangle. It's actually on the midpoint of the hypotenuse because these are bisectors, right? And so your circumscribed circle would look something like that. So for a circumcenter, you can have it in or out or on the circle, okay? So let's move on to the InCenter. The InCenter is created by angle bisectors, and it is equidistant from the sides of the triangle. Okay, so I filled this in as well for you. And let's go ahead and pull out your compass and protractor again, because we're going to construct angle bisectors now. So if you remember an angle bisector, you just need to draw an arc from the vertice, and then pick it up and draw an arc from where that first arc crossed one of the sides of the angle, and then over here on the other side. And we're going to connect these where the intersection to the vertice. So there's one. Now we're going to do it for all three vertices. So I'm just going to do this really quick. Okay, and you can, if you forgot how to do angle bisectors, you can always go back to the previous video that has the angle bisectors in it if you want me to go a little slower. But hopefully you remember how to do this. You create it, there you go. And what you should happen is, once again, it should be on the same point of concurrency right there, okay? So they all should intersect on the same point. So remember what's cool about this one, the InCenter, we said earlier, is that you can create an inscribed circle. So we're going to do that, and I'm going to open up my circle, so hopefully this will work. Last time it didn't work so well. That doesn't look so bad. A little bit off on that side, but you get the idea. That's an inscribed circle where the center of the circle is the InCenter. And remember, what's cool about this is that it's equidistant from the sides, okay? So that means that this length here is the same as this length here, which is the same as this length here, okay? So that's an InCenter. And remember, this is a little review here. So circumcenter is the point of concurrency for the perpendicular bisectors. It's equidistant from the vertices, and it can be in, on, or out of the triangle. The InCenter is the point of concurrency for the angle bisectors. It's equidistant from the sides, and it actually can only be inside the triangle. You won't have an InCenter that is out or on the triangle. Okay? All right. Thanks for watching.